Yes.
Our Father, O Lord, we thank you for the gift of life and we thank you for this lesson. Father, I pray that you may guide us and bless us, that as we study, we may understand everything the teacher is teaching us. In Jesus' name I pray, amen.
Yeah. Thank you. Yes, thank you for the word of prayer. So last time, those people who attended were looking at linear inequalities. And in that lesson, we looked at how we graph linear inequalities on a number line. We went on and had some homework, but also went further and learned how we do the solving. We say that when we have an open circle and we have a closed circle, the way we represent them on a number line is different. So we say that when you have an open circle applies for inequalities that are either greater than or less than. And we say that when you have a closed circle, it applies to inequalities that are greater than or equal or less than or equal. And we say that when you are representing it on a number line, for such inequalities, once maybe they have asked you to represent them on a number line, then you must know that when I have maybe x is greater or equal to -1, then it means you have to come where -1 is. You draw your circle but shaded, and then show the part that is greater than -1. So that's what we looked at last time mainly. And then after we looked at how we can solve linear. Someone is saying my voice is low. So, and then we said, we looked at how we can go on and solve the linear inequalities. So basically that's what we looked at last time, and that's where we are going to start from. Okay, now from that point is okay. Someone's saying it is fine. Okay, fine. So that's where we are going to build from. And I want you now to come and write your heading, solving linear inequalities. Last time we did some, but now we are going to involve in the multiplication and then the division. So write your heading as solving linear inequalities. Solving linear inequalities. Okay. Let me know if people have finished. So I want you to summarize that, the two key points when it comes to solving linear inequalities. So you are going to allow me to disable video. So we are writing. When you finish, you just let us know in the chat that I have finished. So we are writing, those who have just come in. Okay, I think people have finished. Okay. Now, what do I want to emphasize is that whenever we are dealing with inequalities, these two inequalities, when you are multiplying or dividing, once you are having a negative number, take an example, you have negative 3x greater or equal to maybe 9, and you reach a level whereby what you are going to divide with is a negative, it means that this sign you have is going to change. In case it has been a greater or equal, it will change to a less or equal. In case it has been greater than, it changes to less than. So at that point, when you start dividing, that sign has to change. In case it is like here, I'll now change the sign and I say less or equal to 9. But when I'm dividing, I show that I'm dividing. So at this stage, when you are dividing, is where that sign changes. And therefore, you conclude that x is less or equal to -3. Okay. So I think we can now look at an example. Okay, so we have this is our first activity and we want to solve it. Now we are going to say that 12 minus 2x is greater or equal to 6. So we say that what happened is that the way we deal with solving any equation is the same way we deal with this kind of equations. So you consider your inequality as an equal sign. So when you look at 12, 12 is on opposite side of the inequality. So meaning in order for us to take it the other side, we shall always subtract. So I'll say 12 minus 12 minus 2x is greater or equal to 6 minus 12. Since it is positive this side, once the crosses becomes negative. So 12 minus 12 is 0. So I end up with negative 2x is greater or equal to 6 minus 12 will give us negative 6. Now, once we reach at that point, you ask yourself, you'll have -6. So we have to remove this -2. So what do we do? So we shall say that -2x is now at that point when you are dividing, you change your sign immediately when you are going to divide. So the moment you say divide by -2, change your sign less or equal to -6 out of -2. At this point is where you must change once you say out of -2. The moment is a negative, then you must change your sign. So this negative and a negative will reduce. So you remain with x less or equal to -6 out of -2. We shall have 3. And therefore you conclude like that. Okay. Let me hope people we have understood. Yes, this is the point I want us to be very careful. That whenever you are dividing or multiplying by a negative, you must change the sign of the inequality. So when you finish, you let me. Yes, a question? Yes, Mike.
Yes, I was inquiring about like when you're minusing 12 minus 12, it must never be a positive, so it's a negative. You always subtract, you must never add
Yeah,
12 to 6.
when it is positive, you subtract. When it is negative, you add. Are you getting it? Like the
Like
way you deal
like
with, yes. Yes?
when the 6 is positive, you subtract. When the 6 is negative, you add.
Yes. Like whenever you are crossing the equal sign, the sign reverses. In case it has been positive and you are going to cross, it becomes negative. In case it has been positive, as long as you are going to cross any equal sign or an inequality sign, the sign changes.
Okay.
Mm.
Thank you, sir.
Okay.
Teacher,
Yes.
may you please go back to the notes? Me, I've just joined.
Oh, okay. I think, but have you understood what we have written?
Yes.
That is the best. Yes, the notes were explaining that part, that when you are dividing or multiplying by a negative, then you must change the sign of the inequality. But I will send you the work. I'll send you the work.
Cha, can you make me an admin on the group so that I can send messages.
Okay, we shall talk about that. We shall talk about
Yes.
that. Okay, so I think everyone has finished. I think everyone has finished. Okay. Okay, now we are going to the next one. Now, when it comes to this one, still we do the same mathematics. But what is important, you must know the sign change. So you have 9 minus 10x is greater than 48 plus 3x. Always first collect the like terms. When you look at 9 is positive, and if I'm to proceed this side, it will become a negative. So I'll start, I say 9 minus 9 minus 10x is greater than 48 minus 9 plus 3x. So 9 minus 9 is 0. So I get negative 10x is greater than. Then in case you are not good at the mental math, then you get your calculator and you find out what is 48 minus 9. So when you place 48 minus 9, you are going to end up with 39, then plus 3x. Now, after obtaining that, you have not collected the like terms fully because you have 3x and you have an x on two opposite side. So what you do, you change it again. You make the 3x cross. So I'll have negative 10x minus 3x is greater than 39 plus 3x minus 3x. Because this side is a positive, once it crosses, the sign will have to change to a minus. So negative 10 minus 3x, this one will give us negative 13x is greater than 39. So once we reach at this point, you are going to divide. So we have said that at this point, when you are dividing, is where you need to change the sign. So I will say negative 13x divide by negative 13. Our sign was a greater than. So I will change it to less than 39 out of negative 13. Now, after reaching that point, I divide. I get my calculator, or I can use my head to divide. So negative 13 and negative 13 reduce, so I remain with x less than 39 divided by negative 13 will end up with negative 3. So I stop at that point. Members, let me know in the chat whether you have understood. In case you have understood, you can just say yes. Okay, I think members are there. Yes, Marcus.
Yes, I was asking, like that 3. Why did we like change it to a negative when it's moving to negative 10x?
You're saying?
That 3x, why did we change it to a negative? Why did we subtract when we're moving to 10x?
Why didn't we subtract?
Why did we? Yeah.
Yes, one. Why we didn't do what?
Why we subtracted?
The reason
When
why.
it's like.
Okay. The reason why we subtract is that this is a change of a sign. It's like when you are dealing with the real equation, Mukoyo, when you have x plus 4 is equal to 5, how do you deal with 4? How do you remove this 4?
You subtract.
Yes, so that is the same thing we do.
Okay.
That is the same thing we do. Hope you have understood. Okay, so let me hope people have finished. No, the Martha, any side, it is okay. So any side, it can be okay. We are trying this now. Okay, let me hope people are trying. Yes, Pesta.
Can I give my answer?
Yes, give your answer.
X is less than or equal to negative 5.
X is less than or equal to -5. Okay, thank you, Spencer. Karen, are you getting the same answer? What about Elliot, Einstein? Einstein, are you getting the same answer? Okay, thank you. We can now check out and see whether we have the same answer. I'm seeing some having -3, others -5. So we are going to find out what is it. So we can start by saying 2x minus 7 plus 7 is greater or equal to 5x plus 8 plus 7. Now that we have a -7 this side, when it is crossing over, it becomes a plus. So that means that's why we keep on adding. So I'll have 2x is greater than 5x, then 8 plus 7, we shall end up with 15. Now, when I reach here, I make sure I bring the 5x this side. That this side being a positive, when it crosses, it becomes a minus. So I'll say 2x minus 5x is greater or equal to 5x minus 5x plus the 15. So 2x minus 5x gives us -3x greater or equal to 15. So we have said that the moment you reach a point where you are going to be dividing by negative, change the sign. So I'll say -3x out of -3 less or equal to 15 out of -3. So the -3 and the -3 will reduce. So we remain with x less or equal to -5. So those, yes. So those who were getting -3, kindly check out Jonah, Darren. Yes, check out on what? Yes. So that is it. So we are going to continue. But please, I know some of you may have gotten something like this. Please also, this one is okay. It is the same thing. Like in inequalities, if you interchange, you bring this one this side, and this one comes this side, also you change the sign. So when x comes this side, it becomes x, the 5 goes the other side, so also you change the sign. So in case, I know there are people who took 2x this side. So in case you had taken your 2x the other side, you would have ended up with something like this. So also this one is a correct answer. So do not worry that it is wrong. And for people who did like that, I expect that you should not change the sign because you are dividing by a positive number. Okay, I'm going to clean this board and then we proceed to another number. Okay, can we also try? We are trying. So we are trying. Some people are getting 4. I'm saying 4, 4. Okay. Yes, Spencer?
My answer is y is greater than 4.
You are getting?
Y is greater than 4.
Y is greater than 4. Okay. Okay, thank you. Okay. Karen, hope we are getting the same answer. Gloria, hope we are getting the same answer. Sache, Joshua, Tracy, Hanake, hope we are getting the same answer. Okay. Elio, Petrina, are we getting the same answer?
Yes, teacher.
Okay. Petrina, can you first give us the first steps you took?
I first multiplied 3 by both 2y and 6 to give me 6y plus 18 less than
Okay.
8y plus 10.
Okay, good. Continue.
Then I had 18 minus 18. Sorry, 6y plus 18 minus 18 is less than 8y plus 10 minus 18,
Yeah.
giving me 6y is less than 8y.
Minus 8. Continue.
Then I had 6y minus 8y is less than 8y minus 8y minus 8, giving me negative 2y is less than negative 8. Then I rearranged the statement. Then I was like 8y, negative 8, sorry, no. I was like negative 2y out of negative 2 is less than, no, is greater than negative 8 out of negative 2, giving me y is greater than 4.
Okay, thank you. That is correct. Yes. Yes. So Nora, I think you have just come in, but we said earlier on that whenever we have a change in the sign of the inequality, whenever we are dividing or multiplying by a negative, we shall always have our inequality reversed. A negative changes the direction. So negative changes the direction. So that's why we keep on changing. Whenever you meet a negative shows a change in the direction. It is even like whenever you wake up maybe in the morning and you meet someone who is negative, just know you can change everything you had planned for in a particular day. Just imagine you wake up early in the morning, someone tells you, you know what? You are going to fail. So that one alone can change everything we had planned for a particular day. Okay, now I'm going to ask you also to summarize. We are going to look at what we call compound inequalities. Okay. Okay. So we are summarizing. We are summarizing. Yes, I want you to summarize. Let me hope people have finished too. Yes. Let me hope people have finished to summarize. Now, when we talk about compound inequalities, we are referring to those inequalities that have more than two inequality signs in them. Whenever you meet an inequality that has two inequality signs, take an example. In case I give you numbers 4 less than x less than 8, I know very well that in between these two numbers, I have numbers like 5, like 6, like 7. So this one is what we call a compound inequality. So how do we solve a compound inequality? We have two approaches we can use to solve a compound inequality. So I'm going to teach you both approaches, and then you choose which one is easier for you. Method number one. The first approach is for you to separate and you solve the inequalities in parts. Take an example. When you look at this inequality, I can choose to solve this inequality by first solving that part. After solving that part, I will come and I also solve this part. So I'm going to first solve the blue one and then I can solve the red one. Or you can start with any. So in case I'm to solve the blue one, I'll say 2y plus 7 is less than 15. So this will give us 2y plus 7 is less than 15. So what will I have? I'll have 2y plus 7 minus 7 is less than 15 minus 7. So this will yield 2y is less than, when you get 15 minus 7, you'll end up with 8. Meaning that now you're going to divide by 2, divide by 2. So your y will be less than 4. So this will be less than 5. Now, after solving that one, go to the next one, the one in red. So the one in red, I will say 3 is less than 2y plus 7. What am I going to do? Still, I do collect the like terms. I make sure the 3's are on their own side and the 2y. So you choose what you want. Either you bring the 7 this side, anything. So I can say this is 3 minus 7 is less than 2y plus 7 minus 7. So when you say 3 minus 7, you are going to end up with negative 4 less than 2y. So since I want to obtain y, I'll divide by 2, divide by 2. So I'll have negative 2 is less than y. Now, what am I going to do? Since this was a compound inequality, it means that my answer is also going to be in form of a compound inequality. Those people, I have told you earlier on that whenever you have an inequality, which is negative 2 less than y, you can as well write it in another format by interchanging. When you can bring the y this side and take the negative to the other side. So you write y is, now the sign also will change. So it will be y greater than negative 2. Now, what are you going to do? You are going to come or use the number line to understand this better. In case this is my number line, I have 0, I have 1, I have 2, I have 3, I have 4, I have 5. Then I have negative 1, -2, -3. Now, when you look at the first one, it's telling us that y must be less than 4. What does it mean? Y less than 4, it means when I come to my inequality, I'll draw a box and then I'll show that this is the less than. Then the second one, it shows us that we must have our y greater than -2. This is y. So this is greater than is this side. Then I ask myself, where do those two inequalities meet? So when you look at those two inequalities, you can notice that they are intersecting in between these two regions. And therefore, my answer is going to be -2, since the lowest is -2, less than y, less than 4. And this is going to be my, I'll stop at that point. Kindly let me know whether you have picked something. I'm happy Darren has the answer already. Okay, thank you, Darren. So that is the first approach. So first write that approach, and then I show you the second approach. Okay, I think people have finished. I'm going to clean my board. I'm going to clean it. Okay. Now, when I clean it, I'm going to teach you the second approach. Now, the second approach, we have 3 less than 2y plus 7 less than 15. What we do, whatever you do, you start with the middle. So what you do is that what you do on the left, you do it on the right. So I can say, and now this one is positive. So I will make it cross this side, and I will make it cross this side. But whatever I do this side, I do it this side. So I can say 3 minus 7 less than 2y plus 7 minus 7 less than 15 minus 0. So then after I ask myself, what is 3 minus 7? So 3 minus 7 is -4 less than 2y less than, I say 15 minus 7, which is 8. So whatever I do on the left, I do it on the right. So I don't do it on one side. Now, once I reach here, I'm going to remove I. Since I want y, I will divide by 2. So I'll say -4 out of 2 less than 2y out of 2 less than 8 out of 2. So -4 out of 2 is equal to -2 less than y less than 4. So that is my second approach. So you choose the approach that is easier for you, the one that you feel you are more comfortable with. Okay. So let's write that approach as well. Members, have we understood? You can unmute and you tell me. Members, have you understood?
Yes, sir.
Okay. Yes, Darren?
I'm asking, how about if the compound inequality you had to divide the sides by a negative?
You interchange. You change the signs. Okay, let's know if we are finished. You are going to try for me one. Try for me number 1 and 2. We are doing number 1 and 2. So let me hope you are finished. Okay, good. The answers are correct. Karen, that is okay. Marcos, that is okay. And Darren. So let's find also for number 2. Okay, perfect. Those answers are correct. Yes, the answers coming in are correct. So please make sure you get those answers. Okay, so I'm going to continue. Members, let me know whether I can continue. Okay, people want to do also number 3. Kindly do it. Primas, you can do number 3 if you want. Okay, okay, Primas has in fact finished. Oh, okay, okay, okay. Okay, Karen, that is okay. Prima, Spencer, okay. I think we can continue. Now, I want you to take a screenshot. This is part of the exercise you try out in your free time. I picked some few word problems, but these ones are, I want you to try them out in your free time, just to try out and see whether you can be able to attempt. But I'm going to share the work in the chat after, such that you can be able to try out. Okay, now like I told you earlier on that we are going to be needing our graph papers. So kindly, we are going to look at graphing of linear inequalities. So I'm going to ask you that we are going to first write our heading, graphing of linear inequalities, and then we shall start from there. So I want you to first summarize. In case you have a graph book, you can write even in the graph book. In case you don't have, write in your book. And then in case you don't have a graph book, you don't have a graph paper, you are going to improvise and use something. Let's know if we are almost. Okay, okay, good enough. Everyone has finished. So let us start. Now, as we start, I want you to take note of two things. One is that whenever we are representing an inequality on our graph, when we have greater than or equal or less than or equal, here we use a borderline. Okay, so we are saying when it is greater than or equal or less than equal, here we use a bold line, a line that is bold. Take an example. When I have x is less than or equal to -2, and I'm looking for the values that are less than or equal to -2, those values can be any value that is less than. You can, here for this set, I'll start with -2, -1, 0, 0, okay, okay, I want values that are less than. So we shall have, okay, let me start. So values that are less than or equal to -2, we have -2. We have, you can just come to your number line. This is our number line. This is 0. This is -1, -2, -3, -4, -5. So values that are less than or equal to -2. You look at -2 and then you look at this side. So you mention -3, -4, -5. Now, this region that has the values that satisfy the inequality is what you call the wanted region. Then this side, which has values that are not satisfying the inequality, we call it the unwanted region. So always, when we are dealing with our graph, always we are going to be shading the unwanted region. the region that is not satisfying the inequality. Take another example. When they tell me x is greater than maybe 5, I will know that the values that are greater than 5, we have 6, I have 7, I have 8, 9, and the rest of that. Now, the moment I come to know that these are the values that I want, so in case I'm graphing, the region which has those values of 6, 7, 8, 9 is what we call the wanted region, because it satisfies the inequality. Then the region that doesn't have those values, we call it the unwanted region. So when you are shading, we are going to be shading the unwanted region, that region that doesn't satisfy the inequality. Kindly let me know whether that is okay. Have you picked that? What we call the wanted and the unwanted? You can unmute.
Yes.
Is everyone fine with that, members?
Yes.
Okay.
Yes.
Okay.
Teacher.
Okay, good. So now I don't want you to mute. Leave your microphone, but make sure your background is muted. Okay, now we are going to plot this. Now we know that when we are plotting a line, now we are going to use it. So when we are plotting a line, this one is a line. What do? You will need these three things. The first one is that you have your inequality. This is our inequality, which is x less than -2. Number 2, transform that inequality into an equation. By transforming an inequality into a region into an equation, it means that remove the inequality sign, this inequality sign. So I'm going to say x is equal to -2. So why are we putting an equal? We want to put something that is easier to plot on our Cartesian plane. So what you do, where there is an inequality sign, put -2. Then the third thing is for you to know the nature. The nature of the line you are going to draw. What nature is it? By nature, we are looking at, is it a bold line or is it a dotted line? A bold line, those are the inequalities that have greater than or equal or less than or equal. A dotted line has greater than or less than. Members, looking at this inequality, what is going to be the nature? Dotted, bold.
Dotted.
Dotted. Very good. Dotted. Very good. Good. Now, what are we going to do next? We are going to plot this line. Now, when you have x is equal to -2, remember, when we are plotting any line, I'll have my x, I'll have my y. What will happen is that what is going to happen is that your x is -2. So all my x values are -2. So in other words, x is -2 is a constant. But when it comes to your y value can take on any values of your choice. Whenever you find that one value is x is equal to that or y is equal to that, make sure that value, you maintain it constant. But your y value can take on any value of your choice. You can say 0, you can say 1, 2, 3. So the y values can be any value of your choice. But x, since they have told us that x is equal to -2, -2 must be maintained constant. Members, is that fine?
Yes, teacher.
Yes, sir.
Okay, so the points we are going to plot, we are going to have -2, 0, -2, 1, -2, -2, and -2, 3. Those are the points that we are going to do the plotting. Now, after that, members, can you first write? I want us now to go to our graph. We can start now pulling out our graph.
Teacher, how about if the unknowns are neither x nor y, like if it's D?
Oh, no, now we are not going to deal with those ones. We are going to, but in case you find D, you can consider it as X or Y. Yes, but we are going to mainly look at things of X and Y. Hope that is okay. We are going to mainly look at that.
Excuse me, teacher. About if maybe the y
Yes?
y as the
What about if the y has its coefficients?
We are going to look at that one, how we plot those lines. We are going to look
Thank
at
you.
the how. Yes? Okay. Okay. Have you finished, right?
Yes.
Okay. We'll give a minute to those who have not finished.
Finish.
Finished, yeah? Okay.
Yes.
Okay. Now
Yes.
okay. Good. Now we are going to go to our graph. This is my graph. Allow me to remove my things. So what are you going to do? When you come to your graph, I want you always to learn to trace out. Tracing out, I want you to trace out good lines, and good shapes. So when I come, I don't have a line, get your ruler. Trace out these borderlines. Let me use red such that I want to look out for these borderlines in your graph. Trace it out. Hope mine is okay. I can. Okay. In fact, let me also use a ruler. That is one of my lines. I'm going to trace out another one. I think now I'm also accurate. Members, are my lines clear?
Yes.
Now, after
Yes.
okay, good. Now, after that, I'm going to get my pen. And I start that this is 0. I can put here, this is 1. This is 2. This, I think, let me look for a good color. This one is disappointing. This is 1. This is 2, 3, 4, 5. And then I'll stop here. I'll come this side. I say, since I've jumped 2 centimeters, I can also jump here too. This is 1. Oh, but I think we had, was it less than what? What was the inequality? Less than -2? What was the inequality?
It was less than.
Less than
Oh, okay, less than -2. Okay, now allow me, because I need to have negatives. Okay, so since I need to have negatives, allow me to put them there. Now for you, make sure your graph, you have the negatives. Me, I'm putting them there. So make sure you have your negatives there. Make sure you have the negatives there. So I'm going to put it here now. Make sure you have the negatives on your graph. Okay, then I'm going to come and I write. Okay, sorry. So come and write. So I have, this is my graph is 0. I have 1. I have 2. I have 3. Then I'll label that this is my x-axis. I'll come here. This is my -1. This is my -2, like that. And then I can come up here This is my line. I say this is 1. This is 2, no problem. For you can have a length 1. This is -1. So then when I reach there, I will start the plotting. Members, what was the first point we had to plot?
Zero.
-2.
Negative
0.
0.
You plot -2, 0 is here. -2,
And
1 is here. -2 is here. Negative. Now, that is my line. Now, members, I want you to take note. One is that whenever you have a line, x is equal to -2. X lines are always lines that run vertically. They run vertically like this. So that's why our line is going to be a vertical line. And then we have said that this line, we are going to draw it dotted. So those who have finished, draw your dotted line. Put your ruler and draw it dotted like that. And after, you are going to label it. X is equal to -2. You label it. Have you finished to draw your line? Has everyone finished?
yes.
Okay. Now, the next part is we are going to shade the unwanted region. We have said that the unwanted region is that region that does not satisfy the inequality. Now, when you look at our x-axis, we have said that the values that are not satisfying the inequality, we have, let me use black. Since our inequality was x, was it less than -2?
Yes.
So the values
Yes.
that are less than
Yes.
-2 are the values that are of importance. They are the values that are varied, meaning any side that is not less than -2 is the region that we are going to shade. Values that are greater than -2, we have 1, what. So that is the side we are going to shade. So this side is the one which has -3. -3 is this side. So that is the wanted region. So now I'm going to shade this side, which has the positive, which has values that are greater. So I shade it like that. Remember, is that fine?
Yes.
Okay.
Excuse me, Tisha. I thought that you should going to the left hand side since -2 is got from that side. Thank you.
Yes, I beg your pardon?
Tisha, I was like just observing that maybe we should going to the negative side, not to the
Oh, now,
positive side.
okay,
Because
the
the way
negative side.
you stated it's
Okay,
their
like when you
faces
look
that
at
side
the
would be
negative side,
supposed
negative side has the values that are less than -2. It has -3, -4, -5. Those are the values that are smaller. So those are the values that they want, yeah? Have you got it? Yes, let me hope you have understood.
Okay. Yes, teacher. Thank you.
Okay, let me hope people have finished.
Yes.
Oh. Okay, we are going to try another number. Another number we are going to do. I'm going to first clean this board. After clearing, I'm going to put another number. Another number we are going to do, show the region represented by. Now I'm going to ask you, we are going to ignore this. Okay, wait. So we are going to ignore this, and now you're going to put for me here, y less than 2, less than or equal to 2. Then show the region represented by the inequality. Okay, in fact, I'm going to, can we even show the region represented by the inequality and shade the unwanted region.
Excuse me, sir.
Yes.
Not understood the part for shading
Okay. We are going
in the
to do it
previous
from here.
activity.
Yes?
Yes, sir.
Okay. So, okay, I'm repeating from this, using this one. So always the first thing, I want you to obtain your table, a simple table of your choice. But after mastering it, there is no need for you to use the table. Now, after drawing this table, we are going to have our inequality. Our inequality, you extract it the way it is, which is y less or equal to 2. Then after, transform it into a linear equation. By linear equation, now we want to remove this inequality sign and have an equation that can easily be plotted. So I will say y is equal to 2. Then I look at the nature. Members, looking at the nature of less than or equal to, which kind of graph is that? Is it dotted or bold?
Bold.
It is bold. Now, after doing so, we are going to look at the equation we have and then we plot it. So we have y is equal to 2. This one means that when I come to my table, y is equal to 2. It means that you have x and y. Y is equal to 2 means all y values are 2, but the x values can be any value of your choice. So when it comes to x, for you, you can even put any value of your choice of x, but y must always be 2. Now, you are going to ask yourself, when y is less or equal to 2, which values are those that satisfy the inequality? Values that are less than or equal to 2. Which values are those, members? Can we mention them? Values that are less than or equal to 2. The first one will be 2. Which other value is less than 2?
1.
1. Another one?
0.
0.
0.
Another one?
0. Negative 1.
Negative
Good.
1.
Yes.
Negative
Now,
2.
negative 2, yes. Now, these values are what are forming what we call the wanted region, the useful region. And now that they're the ones that are forming the useful region, it means that that is the wanted region. So any region that doesn't have these values is what we call the unwanted region. And when we are showing, we shade the unwanted region. So when I come to my graph, I'm going to come, this is my graph. I'm just estimating. So this is 1, this is 2, 3. I can have my -1, -2. 1, 2, 3. And then I'll have here -1, -2. So I will plot 1, 2. 1, 2 is here. 2, 1, 2, 2, 3. So you'll find that your line is going to be an horizontal line. So it's going to be like this. And since it is bold, I don't dot. So this is my line, y is equal to 2. Now, the region of y, when you are measuring y, you measure it in this format. When you are measuring x, you measure it in this format of horizontal. Now, when I'm measuring the y, that region which has these values, 2, 1, 0, -1, is the useful region of y. So y values, this is, remember, this is the y-axis. These are the y values. So 1, when you check here, you can notice that 1 is here. The values we have mentioned, 0 is here, -1 is here, -2 is here. So all these values are down, meaning that this place down is what is our wanted region, is the region of importance. Now, the other region that has other values is the one that is not important. So now that is the region you come and you shade, that you shade the unwanted region, the region that is not satisfying the inequality. Let me hope my name you have understood.
Teacher.
Yes.
Yes.
Teacher, I want to ask,
Yes.
Yes, sir.
how do you determine the whether the nature of the what of the lines, whether bold or dotted? How do you determine?
Yes, now borrowed comes like when we have less than or equal to. It means that 2 is part of the solution. Less than or equal to. It means 2 is part of the solution. So whenever that number is part of the solution, we use a borderline. So the moment you find greater than or equal to or less than or equal to, it means that number is part of the solution. So use a borderline. In case it is just greater than or less than, then that is not part of the solution. Are you getting it? My name, you can unmute.
Yeah.
Yes, teacher, but
But
I supposed to shade like the whole Cartesian plane. That's
no, you just show that region. You just show that region by shading up. You may not be in a position to shade everything.
not wanted.
Yes. Okay. My name, you can ask. I'm seeing your hand up. So please now, can everyone do it? So everyone is doing that, and we are going to progress to another number. When you finish, you let us know. Yes, the wanted region, yes, is that region that fulfills the inequality, that satisfies the inequality. When you finish, kindly let me know. Okay, Karen has finished. Sheena has finished. Baby Melissa has finished. Okay, we'll wait for more two people and then we'll continue. Yeah. Okay, people have finished. Good. Okay, I'm going to clear my screen, and then still I'm going to use this screen, and then we do another number. Now, another number we are doing is show. Okay, okay, let me now even give you another. I'm going to say shade the unwanted region for the inequality. For the inequality, y for the inequality, y is greater than x plus 1. Okay. Now, the first thing still we are like we have said, you are going to draw your table. But the table is not compulsory members. It's not. It's just to help you summarize. But after you have mastered, no need for you to draw it. So we have the inequality, we have the equation, and we have the nature. Members, what is the nature? What is the nature of our line? It is
Dotted.
Dotted.
Oh,
Dotted.
dotted.
dotted. And what is our equation?
Y is equal to x plus 1.
Y is equal to x plus 1. Okay, good. So I'll do like that. Then I come, I draw my table. So now we are plotting y is equal to x plus 1. Now for this one, be very careful, say x and y. Now, in case they don't give you, in case they have not given you the values for x, you can always assume your own values. So I'm going to assume that I'm going to start from -2, -1, 0, 1, and 2. So whenever they don't give you, make sure you assume. But a good assumption should have some negatives and should have some positives. So what are you going to do? We start feeding. So I can put -2. I say y is equal to -2 plus 1. Our y will equal to what, members?
Negative.
1.
It will equal to -1. So here I'll put -1. I'll come to the next one. I put my -1. So I'll say y is equal to -1 plus 1. Members, what is our y?
0.
Our y is 0. So I'll put here 0. Members, can we complete?
Yes.
Okay, complete. So, members, what do you have where 0 is? Which value do you have?
1.
1. Where 1 is?
2.
2.
2. Sorry.
3.
3.
And
Okay. Members, can we first plot that line? Let everyone plot. We finished?
Yes.
Yeah. Okay, now we are going to our plotting. And now this is where I want you to be very careful. I'm going to remove this such that I can go to my screen. Now, we still draw the line. I've not yet drawn mine, but let me draw. So I assume you have a line of this nature and you have a line of this nature. This is 0. I can say 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, -1, -2. It's a good practice always to label your axis that this is X and then this is the Y axis. Now, what was the first point you plotted, members? -2 what? Kindly tell me. I want to plot it. Members, what?
-2. -2, -1.
Okay. Another one?
-1 and 0 on the y-axis.
Okay. I think you plotted something like that. And now I know our line was a dotted line. So,
Yes.
okay. So your line, those who have drawn, it must come like that. And I want you to label it that
Yes.
this line is y is equal to x plus 1. Members, do we have that line?
Yes, we do have it.
Now, what do I want you to do? One, now we are going to test where to shade. Now, when you look at this diagonal line, I have two regions. I have this region that is up, which I'm calling region A. This side of the line, I have this region that is below the line. What do you do? For you, you choose any point, either below or above. Members, where do you want to choose?
Above.
Above.
Can you choose any coordinate above? As long as it is above in this region. Anywhere, as long as it is above. Which coordinate are you choosing?
-2 and 1.
-2 and 1. Members, that point is here. So I will go back to my inequality. My inequality was y. Was it less than x plus 1? Our original one. What was it?
As in,
It was? Was it like this?
yes. No?
What was it? Was it greater or less? That's what I want to know.
It was y greater than greater than.
Okay, x plus 1. Okay, good. Now, when you look at this point they have chosen, is the point -2, 1. Now, it is the point you are going to use to test where to shade. Your x, this is the x, and this is the y. What do? You substitute them here. Where there is y, put your 1. Put your inequality greater than. Where there is x, put. Our x is -2 plus 1. Now we continue. This is 1 greater than. -2 plus 1, members, what do we get?
-1.
-1. Then you ask yourself, is 1 greater than -1?
Yes.
Now, the moment you find that inequality makes sense, that is where the wanted region is. So meaning that you shade the other region where that point is not. So I'll shade like this. Have we understood that?
Yes.
Yes. If we had chosen
Yes.
a point down here in the region B, you'd find, let me say, I can choose 0, 0 here. 0, 0 is here. It's still down. When you put 0, 0, you are going to find y greater than x plus 1. So when you substitute 0 less than 0 plus 1, you'll find 0 greater than 1. And when you look at this inequality, 0 greater than 1 does not make sense because actually 0 is not above 1. So still means that is the unwanted region. So you shade it again. So, but you test once, You don't need to test. But I was showing you in the other way around. Yes. Now, when it comes to these ones, whereby you have a diagonal line, it is either up or down. Either above the line or below the line, either diagonally like that. Okay. Let me know when you finish.
Done.
Okay, good. Has everyone finished? Can we continue?
Yes.
Okay. Okay. Yes. So now that is how you do that shading. Now, what is next? I want to give you some two numbers that everyone is going to try out. You're going to, those who have graph papers, you are going to try them. But I represent the, okay. I'm going to rephrase this, and then I say, shade the unwanted region, shade the unwanted region for the following inequalities. Inequalities, okay, for the values of x, for the values of x from, we can use from -3 to +3. So I'm going to just put a mark, and those are the ones you are going to do. So number one is here. That is the first one you are going to try out. Number two is here. Number three is here. Yes. Okay, even let me add you one more. Oh, which one? Which one? Okay, and this one. So write those inequalities. That is the activity I want you to do. Yes, and after we shall open the chat. The class monitor will let me know, and then we open the chat for people to post their work. So write those inequalities. Those who don't have graph books, please improvise. You can draw two lines and then you do. Write those inequalities, and then
Excuse me, teacher. The
yeah.
equation is not clear.
The what?
The number E is not clear.
Number E, it is y greater than 2x plus 1. Have you got it? Have you seen?
Yes, teacher. Thank you.
Okay. Has everyone finished?
Yes, teacher.
Okay. Hope everyone has finished. Okay. So I'm going to stop sharing. Yes, Nicole, I repeat, the line is supposed to be dotted when the inequality doesn't have that greater or equal. Whenever you don't see greater or equal, you don't, it is a dotted line. Nicole, have you understood?
I beg your pardon, teacher.
I'm saying, when you find greater than or equal, or less than or equal, here always it is a borderline. The equal means that, like when I say y is greater or equal to 2, here your solution, you will tell me 2, 3, and the rest. 2 is part of the solution. So to show that it is part of solution, we use a borderline. So borderlines are used for that. Then less than or greater than, these open ones, is where we use the dotted line. Understood? Not yet.
Yes, teacher. Understood.
Okay.
Thank you.
Okay. So I think I'm going to share it on your group such that you can be able to catch up. Otherwise, we are going to end here for today. And then I want to wish all those ones that are reporting, starting, I think, on Sunday. I know some of you are going. Are there people who are going on Sunday? Back to school?
Me, yeah,
Oh,
there.
Saturday.
Even some are going back tomorrow. Oh, okay. Yeah. We want to wish you a good.
Yes.
Oh, okay. Okay, we shall open the WhatsApp group such that you